Good afternoon, everyone. Welcome to today's session on smart contracts, variables, and data types in Solidity. I am excited to guide you through this fascinating subject. Let's dive right in. This video provides a comprehensive understanding of the different types of variables and data types used in Solidity smart contract. It covers the fundamental building blocks required to develop efficient smart contracts. Understanding variables and data types is crucial for writing efficient and secure Solidity code. We'll cover the different types of variables, their characteristics, and how to properly declare them and use them. Moving on, value type defines the value we are going to store in a particular variable. For example, they can be of multiple types like integers, booleans, addresses, and enums. We'll see how each of them looks like in the further video. Reference types. There are major three data types in this section. Those are arrays, structs, and mapping. Arrays can be of fixed or dynamic length. Each element in array must be of similar data type. Moving on to structures, they are another example of reference type which groups multiple variables together. That is, each variable can be of different type. Mappings are a reference type like dictionary that associate key with values. Moving on, integers. They can be of three major types: signed and unsigned, numbered lockers, and booleans. Solidity supports both signed and unsigned integers. Unsigned integers cannot be negative. Number of lockers. You can think of integers like numbered lockers, where each locker holds a specific number. Booleans are special type of integers that indicate whether a value is true or false. Booleans are used in conditional statements like if else, while loop, etc. Moving on to the next topic, that is addresses. Addresses in Solidity are like unique postal addresses used to identify houses. They are used to identify accounts and smart contracts on the Ethereum network. Example, whenever you deploy a smart contract, you deploy it at a particular address so that whenever you want to interact with that smart contract, you put its address and then you start the interaction using that particular address. The address must be in a hexadecimal format, which is way of expressing numbers using the digits 0 to 9 and the letters A to F. You can perform various operations on addresses such as sending ether, calling functions, or checking the balance of an address. Enums are user-defined types that can hold one of the several predefined values, similar to a traffic light with values like red, yellow, and green. For example, enums provide a concise way to represent a set of related opinions. Enums are stored more efficiently than strings as they are represented by integer values under the hood. I'll be explaining you how the enums work in the further sessions, or maybe at the end of this session. We'll see how that thing goes. Moving on to the next section, that is storage containers for variables. Variables are like storage containers, that is, they hold the value which they are assigned. For example, we can store the address of the owner of the contract in a particular variable called owner. We'll see how to work with that thing in the end of the session. Labels for data types. Data types are like labels that define what can be stored in the variable. For example, for the variable name owner, we have stored address, so it must be of the type data. So it must be of the data type. We'll see its practical demonstration towards the end of the lesson. State variables are like permanent storage rooms, that is, they hold the data even when the contract is not running, and the data is stored on the blockchain, which is a very expensive method. And on the other hand, local variables are like temporary storage boxes that only exist while the function is running, that is, they are local to a particular function. We'll see the naming convention, how to name these storage and local variables so that it becomes easier for the other person to understand our code. Moving on. Here is the comparison between state variables and local variables. Variables are permanently stored in the blockchain, like permanent storage rooms. They retain their values even after a function call is completed. Whereas local variables are temporary storage boxes that only exist during a function call. They are discarded once the function is complete. Hello everyone, in this session I'll be practically demonstrating you how to build our second smart contract using all the things that we have learned in the previous sessions. So in this session, we'll be making an array to store the integers entered by the users, a structure to store the info about the people, an event to log when a person has been added to that particular mapping, and mapping to store that person with a particular ID. So let's get started. First of all, we'll use the keyword contract to make sure that we are making contract, and we'll start with naming it my contract. we'll write address. Okay, so now first of all we'll be making an array to store the integers entered by the user. So we'll write uint 256 array. Since this is an array, my array, or we name it integer array, and we'll make its visibility public so that everyone can access it. Now we'll write a function to store integers in an array. So we'll write function enter number, enter integer. It requires a uint of 56 integer. This function is public. And we'll write integer array dot push number. So I'll change the compiler version here, that is 0.8.7, and we'll compile our contract. Now we'll select the network, that is Remix VM Virtual Machine Berlin, and we have already selected our contract, so we'll click on deploy. So now that we have created our second smart contract first function, I'll check whether it works or not. So we'll enter an integer, that is 34, and we'll click on enter integer. We get a message that the transaction is successful. So let's check that whether our integer has been entered into the array or not. So here in the integer array, we have to provide the index at which we have to check our value. So since we have inserted only one value, we'll be using the index 0. Now that we have entered 0, I'll click on integer array, and hooray, we have got our value, that is 34. Now that we have created our first function successfully, we'll move on. Now we'll create a structure to store the info of the people. So first of all we'll write struct, we'll name it people, and name will be of type string. It will also contain the age of the person, that is suppose uint 256 age, and also their favorite number, that is uint 256 favorite number. Now let's create a mapping to store that particular person with a particular address. So we'll write mapping. This would be address to structure people. That this will be a public variable, and we'll name it my people. Now let's add a function to add people to this array. So we'll write function add people to mapping. Now since the string since name is of type string, we'll write string memory, which is to be used every time we write a string. We'll give it name, type of the second data, that is age, and number. Since this is a public function, that is it can be called from the inside and outside of the contract, and it doesn't return anything, we'll write. Now to store the address of the sender, we'll use a global variable called message. So global variable used is message. So we'll store it like this: address sender is equal to message.sender. This gives us the address of the person who sent the message. To add the person, we'll write people, and we'll provide with the values. So those are name, age, and number. We'll also emit an event. So first of all, we'll have to define an event first. We'll write event the name of the event, that is person added, and it will contain the address indexed. This is the keyword for an event, index address, and we'll write addr and also the name. Name. Oh, we forgot the index keyword. That is, so yeah. And now we'll emit this event. This will be person added with sender, comma, the name of the person, that is name. So now that we have written our second function, let's try it out. We'll go to this, we'll compile our ethosd.solve and we'll delete the previous deployment and we'll redeploy our function with this particular address. So now, okay, so now let's add a person. So this will be, name will be my name, that is Devansh, age will be 19, and my favorite number is 7. Okay, so now an event must have been logged. You can see it right here. I'll just increase the size of the console. You see this here, logs from event person added, the value of this. Okay, so as you can see here, the event has been logged. Arguments are at the 0th index is the address of the sender, which you can see matches this one. I'll just copy this address and you can see that this matches with the address from which we have deployed. So now let's check whether I have been added to that particular mapping. So in my people mapping, I'll just specify the address, that is this address, and when I put this address as an input and I click on this, I get the values of myself written, that is my name is Devansh, age 19, and my favorite number is 7. Now, okay, so now that we have tried everything that we had listed above, that is all the 4 functions that we needed to create, I would like you to perform an activity yourself. In this function, in this event, remove the index keyword from the name part and check what happens. I'll leave it up to you guys. So thank you all.